Hi, my name is Charlton Trezevant, and I'm here with Zain Malik, PMM of Secret Scanning at GitHub, to show off some of the great security tools included with the GitHub Advanced Security Suite. Secret scanning is an awesome feature that helps keep your code and infrastructure safe by preventing the accidental exposure of secret keys and information inside your code base. I'll pass it over to Zain to break it down.
Thanks, Charleston. We're really excited to talk about secret scanning with you. It's a major problem in application security today, and a big portion of where the innovation is heading. So I'll get started with my slide deck now. So again, my name is Zen Malik. I'm a senior product marketing manager at GitHub. I work on the advanced security team, which encompasses code scanning, supply chain security, and our crown jewel, which we'll talk about today, secret scanning, where our mission is to secure the world's software by eliminating credential-based breaches. So before we get into how secret scanning works and Charlton's demo, let's discuss the problem a little bit. As an industry, we've been talking about shifting security left for a decade now. I'm sure all of you on this webinar have seen some form of this graph before. The reason why we want to shift security left is because it's easier, it's cheaper, and makes organizations more safe and productive. But it's easier said than done. And honestly, it has not been working too well. This is our own internal GitHub data across all of our public repositories. At GitHub, we have over 100 million active users. And this shows just how much GitHub tokens have been leaked over the past few years. Think about how many leaks may occur with partner patterns or your own proprietary patterns in your own repositories. And the truth of the matter is that traditional application security methods are not working to solve this modern problem of leaked credentials. Credentials make up about 50% of data breaches today, and they're only continuing to be more and more devastating attack vectors. Also, these simple mistakes, leaked credentials, developers accidentally exposing them in repositories, they cost organizations like a ton of money. Breaches that start with exposed credentials tend to be the most expensive, as you can see in these two charts. So at GitHub, we're trying to take a unique approach to this. As we're a developer-centric community, we want to build a developer-friendly product. When developers have a product that they like, that keeps them productive, they're more likely to be proactive about security. So now let's get into how secret scanning actually works. Well, first, we make it very easy and simple to turn on. With just one click, you can enable secret scanning at the repo org and soon enterprise levels. You can do this today in any of your public repos, or if you have an advanced security license, you can also do this in your private repositories. Second, what do? Well, we detect secrets. We detect a lot of different types of secrets, our own and our partners. In this example, we're showing a HubSpot secret. We have over 100 different partners signed up to our partner program, including all major cloud providers. And currently, we scan for over 200 different token types. But say you have tokens that are not associated with those partner programs or the providers or the token types that we scan for, you can also implement your own custom secrets too. This is a feature exclusive for advanced security customers, but you can do this across the repo org and enterprise level. And this just shows the different types of places that we detect leaks. We want to detect a leak anywhere software is built. So this shows where GitHub tokens are most commonly found. And this is the thing that drives our roadmap. We want to continue to expand the reach of secret scanning to encompass all developer tools. But not only do we want to detect leaks after the fact, we want to actually be proactive and prevent leaks anywhere we can. And this is done through a feature called push protection, which Charlton will demo as well. With one click, you can also turn this on across the repo org and enterprise level. So here's an example. Again, using a HubSpot API token in a GitHub action file. If I commit the secret and try to push, I'm blocked from pushing. So push protection actually has less than a 1% false positive rate. But in the rare cases we get something wrong, the developer can use the link to go into the UI and allow the secret through. Perhaps it's used in a test, perhaps it is a false positive, or perhaps they're just running a low risk repo and they want to fix it later. We're also going to try to protect anywhere we can. So this is an example of push protection in action in the GitHub web editor. So I'm excited, we're excited to increase the awareness of secret scanning with partners like Xpirit. This is a big year for us. We have a lot of big ships on our roadmap. And these are the principles that guide that roadmap: detect, prevent, and remediate. Now I'm going to hand it over to Charlton at Xpirit to run through the demo of secret scanning and push protection.
Awesome. Thanks for giving us the overview, Zane. I'm really excited to show everybody the powerful features of secret scanning and how you can use them in your repos. So here's our agenda for today. We'll take a quick look at secret scanning and advanced security and give you an overview of both. Then we're going to dive into a series of demos. First, we'll look at how you can enable secret scanning features in your repositories and GitHub organizations. And after that, we'll look at push protection. And finally, we'll wrap it up with a demo of how to write and use your own custom patterns for secret scanning. Let's dive in. So, secret scanning is part of a suite of products from GitHub that is known as GitHub Advanced Security, or GAS. Secret scanning stands next to other flagship GAS products like Dependabot, which makes sure that your dependencies are always up to date and secure, and code scanning, which can run different types of queries against your code base to make sure that you haven't run into security issues or other quality problems. Now, we all know security is important, and there's been a huge push in the industry to integrate more security tools and processes earlier into the development lifecycle. But at GitHub, and certainly at Xpirit, we believe that there's a better approach to doing this, and it starts with great automation and robust tools like secret scanning. Let's take a look at how it works. So, secret scanning. It finds and prevents leaks, but what does it look like under the hood? Every time a user commits and pushes a change up to GitHub, a background scanning process is started. This process runs a secret scanning regex pattern against the codebase. If a secret is detected, GitHub will then reach out to a verification endpoint to check whether or not the detected secret is a false positive. Now, the behavior of this verification endpoint varies depending on the partner that issued the secret. Some providers are actually able to revoke secrets when they're detected by secret scanning. When this happens, the provider will make sure that that token is no longer valid, i.e., if it's an API credential, it can no longer be used to access their API. And following that, they'll also send out an email alert to whomever had issued the secret on their service to let them know that that secret was exposed and has now been deactivated. This integrated lifecycle management is a really great feature of secret scanning, and it definitely provides some extra peace of mind because it makes sure that even though a secret may have been exposed, it can't actually be used for malicious purposes against you or your organization, as long as token revocation is supported by that secret scanning partner. And what's even better is that the secret scanning team is adding support for new token types and new partners all the time. So even if a particular partner isn't quite supported yet by secret scanning, there's a good chance that they'll be added at some point in the future. So without further ado, let's jump into our first demo, how to enable secret scanning. One of the best features of secret scanning is how easy it is to set up and configure. Let's check out the process of enabling secret scanning for a single repository on github.com. First, we'll go to the repository settings pane, and then we'll go down to code security and analysis. Now here is where we'll find the secret scanning settings for our repository. Here's the secret scanning section, and if we just click on Enable, just like that, we've enabled secret scanning for our repository. You may notice a few more options becoming available once secret scanning is enabled. These settings allow us to further tune our secret scanning configuration and enable additional safeguards that prevent secrets from being pushed to GitHub in the first place. For example, we can enable push protection to block pushes that contain secrets before they reach github.com. Additionally, we can add custom secret scanning patterns that will add support for our own custom secret formats. Secret scanning covers a wide range of secret types, but this feature is useful in cases where secret scanning doesn't already support a particular provider out of the box, or if we have a specialized use case. More on that later. So here's a demo codebase that we created for this webinar in .NET. As you can see, the project contains a number of different files: C# source files, Docker files, JSON, and so on. Now, this file contains a real secret. Check it out. In this section, we have a Cosmos DB connection string. So let's go ahead and add and commit this code to our local Git repo to get it into source control. Next, we'll go ahead and push it up to GitHub. Enter my pin here, and up it goes. Let's flip over to our repo on github.com and take a look at the code that we just pushed. It's all here. And if we flip back, we can actually go ahead and compare. Right, here is our app-settings.json file with the secret in it. And if we go to that same file in our GitHub repo, we can see that connection string is also present. So we've been able to spot the secret, but did GitHub? Let's go to the Security Center for our repo and have a look under secret scanning. We see that we do have one alert here, and it is indeed related to a Cosmos DB key inside of our codebase. And check it out. Right here in the results for that alert, it's the exact same Cosmos DB connection string that we expected to find right inside of our repository. We even get some useful remediation steps and recommendations to go along with it. Another great feature of secret scanning on GitHub is how easy it is to manage and get insights at an organizational level. Let's check out the Security Center for our organization and see if we picked up on any of the secret scanning related alerts from the demos that we just ran. Here's the security pane for the GitHub organization that we're running demos in. Check it out. As you can see here, 50% of the open alerts are related to secret scanning. And we can actually see a breakdown of the affected versus unaffected repositories for each of these alerts. Now, if we click on secret scanning, we can see the very same alerts that we triggered earlier in the secret scanning demo right here in the Security Center for our organization. This is a super convenient way to get insights about your security posture overall at an organizational level, all in one place. But what if we want to manage secret scanning settings for our entire org? If we go back to the overview, and then click on Settings, and then find Code Security and Analysis, similar to how we did before, we'll be able to find the secret scanning settings for our entire organization. Now, as you can see, we have a number of options here. For one thing, we can check this box to automatically enable secret scanning for all new public repositories created inside of our organization, as well as repositories with advanced security enabled. Let's do that. From here on, new public repositories in our organization will have secret scanning turned on by default. But what if we want to enable secret scanning retroactively for every repository in our organization? Well, that's simple too. If we click on this Enable All button, it'll let us enable secret scanning for all eligible repositories inside of our entire organization. And usefully, we're also presented with the breakdown of how many repos already have secret scanning enabled, how many will get it enabled, and any remaining repos in our org that aren't eligible for the feature. Now, it looks like both of the repositories that our organization has already have secret scanning enabled, but we're going to go ahead and click this Enable All button anyway. And just like that, we're done. Now let's do the same thing for push protection. Now, with push protection settings, we have two options. First, we can automatically enable push protection for repositories added to secret scanning. And that means anytime a repository in our organization has secret scanning turned on, push protection will be enabled at the same time automatically. We also have the ability to add our own custom resource link to the error message that appears when someone tries to push secrets up to one of our repos. And this could be a link to anything you like, say an internal knowledge base, security policy, or other helpful resource that you'd like to direct developers to if they were to encounter this error message from push protection. And just like with secret scanning, we can click this Enable All button to turn push protection on for all eligible repositories in our full organization. As you can see in this breakdown, one repository already has push protection enabled, and an additional repository will have it enabled just as soon as we click this button. But what if you want to stop leaks before they happen? Well, that's where push protection comes in. Let's check that out and explore it in more detail. So we know that when we have secret scanning enabled, GitHub will scan the contents of the code that we're pushing to detect any secrets that it may contain. When we enable push protection, we actually go a step further though. Instead of just finding secrets in our codebase, GitHub will actively reject pushes that contain known secrets. Let me show you how it works in a demo. To enable push protection, first we have to enable secret scanning. So we'll go up to Settings, we'll go again to Code Security and Analysis, and finally scroll down until we can enable secret scanning. Once secret scanning is enabled, we'll be able to turn on push protection as well. Let's click the Enable button for it. And just like that, we've enabled push protection. So let's go ahead and try to push some code to this repository that contains a secret. So if we go back to VS Code, we can see that we have that same app with that same connection string for Cosmos DB. So let's go ahead and try to commit and push this code base to GitHub again. So we'll add, and then we'll commit. Next, we'll go ahead and try to push this up to github.com. I'll enter my PIN again here, and let's see what happens. So the push started, but now we've gotten some kind of error message. Check it out. This is an error message from push protection, and it's showing us that it detected a secret in the push that we were attempting to send up to GitHub. The error message details the reason this push was blocked, and it also shows us some useful information that we saw earlier in the Security Center, including the affected file, information about the secret that was detected, and so on. Now, we also have the additional option of following a link to unblock the push, and this would allow the secret to go through to github.com. Now, we don't actually want to do that in this case because push protection is blocking a real secret. But it is a useful feature in cases where maybe we got a secret scanning error triggered by a false positive or something like that. Last but not least, let's talk about custom patterns, one of my favorite and perhaps the most powerful features of secret scanning. Custom patterns put you in the driver's seat and make secret scanning even more useful. With these, you can adapt the full suite of secret scanning features, including push protection and alerting, to work with any format you can specify in regular expressions. Before looking at these hands-on, let's talk a bit about the workflow for developing custom patterns. It's all based around regular expressions, where you define a matching pattern for the secret, as well as patterns that might occur before or after the secret. I'll show you how that works in a bit. Once you've started developing your custom patterns, GitHub makes it easy to test them with your own inputs, as well as do dry runs. These are great ways to refine the pattern and reduce any false positive rates to an acceptable level. When you're finished with developing the secret scanning pattern, you can easily deploy it for a specific repository or even across your entire GitHub organization. Finally, if you're a service provider, you may also want to consider joining GitHub's Secret Scanning Partner Program. This is a great way to protect both your platform and your users, and you can find more information about this program in GitHub's Code Security Knowledge Base. So let's talk about custom patterns. First, we'll go up to Settings, and then head down to Code Security and Analysis again to find our suite of different settings for secret scanning. You can see that we've got an area here for custom patterns, and I've got one already made. Let's edit it. All right, so let's break this down a bit. We can provide a name for the pattern, and then we give it a regex to actually specify the format of the custom pattern. We'll come back to this in a moment. Then you also have regular expressions for before and after the secret. If you want to narrow things down even further, you can add additional match requirements as well. We're not going to do that in this case. And then you can provide a test string down here. So let me bring in a test string and kind of show you what's going on. So I've got this custom pattern for essentially picking up private keys in PEM format. And you can see that the body of this is highlighted, right? So we're actually picking up the secret key material between the beginning and ending delimiters of the PEM. But if I put in, say, a different type of private key, let's look at, say, OpenSSH, this isn't highlighting. And the reason is because my regular expression specifies a 64-character line length. Now, the delimiters at the beginning and end will match that before and after secret. But to get the body to function correctly, let's replace that limited line length with a plus so it works for any arbitrary length. Now you can see that we've got it highlighted, which is perfect. And that also still works for the previous format that we were testing from OpenSSL, which is great. Awesome. So we've run our tests. We'll save and do a dry run. We didn't find any matches yet, but let's go ahead and publish this pattern so that it'll be active inside of our repository. And then we'll give it a real test to see if it works. So I'm going to show you something cool. Let's go ahead and make a new issue in our repository. And let's just, inside of this issue, we're going to drop an SSL private key and an SSH private key to see if secret scanning actually detects these things being exposed. Now, if we go to the Security Center, we see we now have 3 alerts open for secret scanning. And both of those were triggered on the custom pattern that we defined earlier. And indeed, we can see it references the issue where we did actually expose those private keys, and it's the same key that we posted in the issue. And we get distinct entries here for each of the detections that were triggered. So we get one for the SSH private key and the other for the SSL one. Before we close out this webinar, I wanted to share some of the amazing resources that myself and the other GitHub experts at Xpirit have put out in the world. We have tons of great information about best practices, cool features, and other tips and tricks, and nothing makes us happier than seeing others benefit from the knowledge that we share. From our own expert magazine to expert Q&A sessions, conference talks, blog posts, online courses, workshops, and even published books, every one of us is working hard to share a wealth of information with anyone seeking to learn more about the GitHub platform. Check it all out at the link. So we hope this webinar has given you a solid understanding of secrets, from what they are and why they're important to protect, to how GitHub secret scanning helps you work with them safely. Now we've got even more exciting information in store to share with you on GitHub Advanced Security, so stay tuned for future webinars. But in the meantime, thank you so much for attending this one. Zane, any parting words?
Yeah, I think one of the major issues around secrets that are exposed is just the lack of awareness. So thank you for joining today's webinar. If you have any further questions, our information is below. Feel free to email us and we'll connect you with the right resources. And thanks again to the Xpirit team for joining us on this webinar.
Thanks for having us.